Welcome to The Bootloader. I'm Todd Kurt.
And I'm Paul Cutler. This is episode 9, and the show works like this. Todd and I have each brought 3 things to share. We'll chat about each for a few minutes, but no more than 5. And if you want to learn more, visit the detailed show notes at thebootloader.net. Todd, what's your first one?
All right, so I'm going to start it off really nerdy. I like the little tiny microcontroller boards that do various fun things. And I just discovered one a couple weeks ago called the M5Stack Cardputer. Like computer, but card. It's about the size of a deck of playing cards. And it's got an ESP32S3 chip in it, which means it does Wi-Fi and Bluetooth. And it's got a little screen and a little keyboard. And it's all in a little case. So it's almost like a little consumer electronics product. It's pretty well designed, industrial design-wise. But it's got a full QWERTY keyboard in something the size of a deck of cards. So the buttons are very small, especially for my big old meaty mitts, but they work. And so it's a pretty useful little device just right there, just with those features, just with the screen, keyboard, and having Wi-Fi and Bluetooth. But it's also got a microphone and an I2S amplifier to a speaker. It's got a micro SD slot. It's got infrared, I think, both to receive and send. And then it's also got a 1400 milliamp hour battery. So it can just be this portable thing you can have in your bag to play with all the time. And on top of all this, it's only $30. So I got a couple weeks ago, been playing around with it. The little app that comes with it is actually remarkably full featured. It's like a little, almost tiny little OS. You can choose from different little apps. There's a pretend you're a Bluetooth keyboard, pretend you're a Wi-Fi keyboard. There's, scan your Wi-Fi. There's a full Python REPL. You can just start and then start doing MicroPython, a bunch of other stuff. And of course, all that code is available, so you can download and look at it and everything else. But because it's ESP32S3, it works with all the other software that we've been using in Arduino and CircuitPython all these years. Like there's a CircuitPython build for it, which you can just run it, and it sets up the display and all the keys and stuff for you. So you can just start going doing CircuitPython stuff with it. While it is a Chinese-based company, M5Stack makes all these interesting little sort of pluggable computer things. They're sort of like the Cutie Pie in size, but they have a much higher density pinout because they're made to be plugged into PCBs rather than plugged into a breadboard. But you can get them shipped from the US from electromaker.io. And so I got a couple. I've been playing around with them. I'm a big fan of the ESP32S3 chipset because it can do Wi-Fi and it's very fast. It's good for doing synthesizer-y stuff. So I've been doing little synthesizer-y experiments on it because, hey, it's got that speaker output that's hooked up to an I2S audio DAC. And yeah, it's I think if someone wants to have something to play with that's really tiny and you can just kind of hide it in your bag, I say it's a good $30 well spent.
I've been following along with some of the pull requests to get that up and running with CircuitPython. I didn't realize it was only $30.
Yeah.
That's amazing how much functionality comes for that price.
Yeah, I mean, especially because it's got this full multi-piece injection molded enclosure with a bunch of buttons and stuff. It's like, just the injection molding of that is pretty expensive. And so it seems like they approached it as almost a consumer product. Like how much consumer productness can we fit with a retail price of $30 and using ESP32? And they just went from there. And so, yeah.
What comes preloaded on it? Is it MicroPython?
It's an Arduino sketch, I think, that somehow is embedding MicroPython. I need to look into it more. I unfortunately blew it away because I was playing around with CircuitPython stuff. But on my to-do list is I think I found the code that came on it. I want to recompile it and reload it and see if I can get it and see what's actually going on, because it was amazing what it did. It had all these little apps and you can go back to the main app launching screen. It was kind of surprising how good it was.
You'll have to give us an update next episode.
Yeah, totally. All right. So what's your number one for this week?
My first one is RadioFreeFedi, and I'm all in on the Fediverse. I really enjoy using Mastodon for social media, PixelFed for sharing photos, usually of which records I'm playing, and then there's RadioFreeFedi. Longtime listeners know I'm really into music, and I have to give a shout out to Axwax on Mastodon for introducing me to RadioFreeFedi. Axel, if you're listening, thank you. Radio Free Fedi is an online music stream dedicated to independent artists on the Fediverse. It turns out there's a whole world of artists making music on the Fediverse in every genre. If you visit radiofreefedi.net, you will find 3 channels you can listen to. The first is the main channel. You'll hear songs from almost every genre, and as the website says, some of the songs will challenge you with music you may not normally listen to, but it is curated, and if you don't like a song, another one will be on in just a few minutes. The second channel is called Comfy, which smooths out the edges for those who might want a softer experience. This is my go-to channel in the mornings when I want something a little quieter than the main channel. And then there's a specialty channel which hosts a block of songs around a theme which changes every hour. They also, at the top and bottom of the hour, have a little spoken word section. Sometimes it could be a poem, but it's a really neat feature that they break up the music with spoken words, and people can actually volunteer to read station IDs as well. I need to work up the courage and volunteer to do that because I really enjoy Radio Free Fedi.
That sounds fun, yeah.
If I was smart, I would have mentioned Radio Free Fedi on the last episode, because in May, they host FediVision, which just wrapped up. It's a take on Eurovision where Fedi artists submit songs from fictitious countries, and listeners can vote on their favorite songs. It was really fun listening to all the entries on the special channel that Radio Free Fedi set up to stream those songs. Going back to my shout out to Axwax, who tirelessly promotes musicians on the Fediverse, especially on Bandcamp Friday and Faircamp Friday. If you haven't heard of that, Bandcamp used to host Bandcamp Fridays where 100% of the music proceeds would go to the artists and none of the fees went to Bandcamp. And it started during the pandemic as a way to help boost those artists' revenue streams because they couldn't tour, for example.
Yeah.
Well, Bandcamp's been sold twice in the last few years, and an alternative open source solution has popped up called Faircamp. Musicians can install Faircamp, point it at a directory of songs, and it will create a static website you can host to stream the songs, and it integrates with payment processors like Stripe, so you can offer purchases to your listeners as well. If you enjoy music and if you enjoy being on the Fediverse, I strongly encourage you to check out Radio Free Fedi. There's links in the show notes to some of the artists I've discovered that I like, and if you like Radio Free Fedi, check out their State of the Station on how they're doing and how to support them. Running an online radio station isn't cheap. And if you come across an artist you like, share it on the Fediverse and let others know.
That's really cool. I really like the Faircamp thing because it's a static site generator geared towards making playlists that you can listen to, stream audio online from various websites. That seems to be one of the places where the static site generators I've seen kind of fall down. They don't really have a way of serving up MP3s or whatever, and so yeah, that's pretty cool. I'm a big fan of online streaming radio stations. I've been a big supporter of Soma FM, but they're like more traditional, like quote unquote real musicians that have record deals and such.
Sure.
I really like the hey, let's all listen to each other's stuff because it's so nice and easy to make your own music now.
Yeah, and Faircamp's really neat. If you don't have cover art, it's got a generative AI built in, so it'll create cover art for you.
That's hilarious.
Yeah. What's your next one?
All right, so I build a lot of little circuits. I make PCBs to house those circuits or to be the infrastructure for those circuits. And for about 20 years, I've used this program called Eagle to design those PCBs. It was a okay program. It's gone through multiple multiple owners over that 20-year period. The latest of which is Autodesk, and Autodesk initially improved it a lot, but in the last several years, like last 4 years or whatever, they've kind of abandoned it, and they've officially said in 2026 they're going to stop supporting Eagle at all, which is frustrating because one of the last changes they made was you had to log into the Autodesk authentication servers to use the program, which I assume means in 2026, I won't even be able to open up Eagle anymore. So it's been on my to-do list to shift to this open source schematic program called Kicad or Kicad. I think Kicad is the appropriate way to pronounce it, but I always pronounce it Kicad because I'm American, I guess. And earlier this year, I finally made the jump and I decided that for my next circuit board, I'm going to design it in Kicad. And for every circuit board after that, I'm going to try to do it in Kicad. Looking around, there's lots of instructional material on it, which is on Kicad, which is great, but it's been around for a long time and it's been evolving and getting so much easier to use than it was just a few years ago. And so it's like, well, which videos should you watch? And also for me, I'm kind of this immigrant from Eagle, like which one is more appropriate to me, because I know the concepts of how to do schematics. I just don't know the particulars. And so I found this one really great YouTube channel called PlumPot. It's PlumPot is a couple. It's Carrie Plumstead and JP Potgater. So PlumPot. They had this really great long playlist of YouTube videos that's how to go from installing Kicad to creating the symbols in the schematic and the footprints on the PCB, and to ordering those PCBs with generating the Gerber files that the PCB house needs. And while it is an older series, it was done with Kicad 5. Almost everything that they talk about is relevant, especially some of the more advanced topics, which hasn't really changed much. Like in the last several versions of Kicad, they have made the UI a lot easier to work with, at least to me. Back when I tried this a couple of years ago, I found Kicad kind of weird. And this is someone who has used Eagle for so many years, which has the weirdest UI. But in the last several years, it seems like the usability has just gone over a hill where it's just everything is so much simpler. And that's been really great. So I was able to do some of the just getting started stuff much easier than I could before. But some of these tricky things I couldn't quite get going, and watching the PlumPot videos really helped. Thank you to Carrie Plumstead and JP Pottinger for helping me get over the hump of getting into Kicad, and I'm full-time Kicad person now.
What's been the most challenging part of the transition from Eagle to Kicad for you?
So I think the main thing is in Eagle, in Circus you have a part, like say a knob, a potentiometer, and you have two different representations of that part. You have the schematic symbol that's the sort of semantic how the pot is wired up to your circuit, and then you have the physical layout of that pot solder footprint, which is somewhere on your PCB, like physically, like it's 3 inches over and 2 inches down, and it's rotated 90 degrees and all that kind of stuff. And in Eagle, those two representations, the sort of semantic schematic representation and the physical layout footprint specification, are joined together. And that makes it's a very logical way of thinking about it in some ways, because you're like, oh yeah, I just want to plop down this exact pot. The downside with the Eagle format is that there are literally tens of thousands of different kinds of potentiometer. So you have this one single symbol in the schematic, but you have 10,000 different variations in your circuit board, in the physical reality of it. Is it a horizontal potentiometer that sticks out towards you, or is it a vertical potentiometer that sticks up? It is a 6 millimeter or a 9 millimeter potentiometer. It's like there's all these different variations. And so with Eagle, you could run into the problem where you have in your schematic the choice of which several hundred of these different same looking symbols am I going to use? And whereas Kicad, it's totally separate. You have just the potentiometer symbol that you use when you're drawing schematics. And then at some point later, you have to go through this process of assigning the footprints, where you say, this part needs that exact footprint. And in retrospect, now that makes a lot of sense. But at the time, I was like, how do I take my schematic and turn it into the actual PCB? It just seemed like it didn't make much sense to me. That was like the biggest hurdle for me, was getting over this binding of the schematic to the PCB footprint part problem that Eagle kind of solves invisibly for you.
Has there been something that surprised you on how easy it was to do in Kicad?
Oh yeah, the 3D visualization. So when you're laying out a circuit board and you're putting down a switch and a knob and a display and some microcontroller board, it's kind of hard to tell how that will actually look. And so what are the things one would do to visualize that? That is one of the things I used to do is I would print out on paper a one-to-one representation of that circuit board, and then I would lay parts on top of it to sort of feel kind of how the parts are interacting, because you're looking at a 2D representation, just a flat sort of vector art view of what the PCB looks like, but real parts have 3D height, and they kind of overlap a little bit. Sometimes they have overhangs. Sometimes when you need to place a part, your fingers have to go on each side of it, so there needs to be room on each side of the part so your fingers can actually push the part in, things like that. And so it was really hard. It's like, okay, well, I'll print it out on paper and I'll lay the parts out like a little scale model. Or what I was doing in Eagle is I was exporting a version of it into Fusion 360, which is a 3D CAD program, and finding 3D representations or close enough analogs to the parts I was going to use and plopping them onto this 3D model and then looking at the 3D model. In Kicad, you can just press Option F3 or something, and it will generate a 3D model for you right there. So you can just immediately go, what does this look like? And you can just see what it looks like. You go, oh, okay, it's actually these parts are too close together. I'll never be able to get my fingers in between there. And so you can just start nudging it. And so being able to just really quickly see the visual 3D representation of the board is so cool.
Very cool.
Anyway, yeah, Kicad, very awesome. So, so Paul, what's your number 2?
My number 2 is André Costa and the Pico W Air. So continuing on that Meet the Maker thing I started last episode, I wanted to share a cool product by André, the Pico W Air. Andre's more well known for being the creator of rpilocator, a website and Mastodon bot that alerts you when a Raspberry Pi becomes available for sale online. He was recently in MagPi magazine, who did a great story on him and rpilocator. I'll link to that in the show notes. But he's also created the Pico W Air, a wireless air quality monitor powered by CircuitPython and CircuitPython's HTTP server. I don't think I've seen another product for sale that actually uses CircuitPython's HTTP server. And for just under $13, you get a custom PCB with a Pico W mounted to it, with a connector for a particulate matter sensor and a quick connector for additional sensors, like the recommended temperature and humidity sensor, for example. He also has a particulate matter sensor available as an add-on for sale on his Tindy store, so you could actually bundle them both together. What I think is innovative is not only does it have MQTT, but it takes advantage of HTTP server. Just add your Wi-Fi settings in the settings.toml like you would do in a normal CircuitPython microcontroller. Find the IP of the device, and you can connect to it from your phone or from another computer, and you can view all the stats right there in a web browser, nicely formatted. So you can see what's your air quality, what's the temperature, what's the humidity if you have added those sensors, for example. And since it works with MQTT, it's easy to add to Home Assistant as well. It also has a JSON API, so you can interact with it through the API too. I talked about the Microdot web server last episode and the fact that MicroPython has over a dozen different web servers. CircuitPython has just this one, and I think this is a really interesting use case for it.
Yeah, totally. I really like how he supports multiple ways of looking at the data, like over the net. Like he's got MQTT, HTML, and JSON API. Like that's like normally in these CircuitPython projects, you kind of see these really stripped down examples of how to do one aspect of that. But he's developed a full application that kind of offers all the things you want to have when you have something like a sensor like this.
Exactly. It's a really neat product, and I'll make sure I link to his Tindy store and to follow him on Mastodon in the show notes as well.
Yeah, I'm looking at it right now, and it's great because the whole PCB with the Pico mounted is like basically the size of, it fits in your hand, and it's like the sensor is basically the same size. Like it's made to go just right on top of the sensor. That's great.
Yep. What's your next one?
This is another YouTube thing. So there's this game designer named Freya Holmér, and she makes, I think mostly her job she does for money is she designs tools and shaders for Unity, which is a 3D game engine. And but one of the things that I mostly know her from are these beautiful YouTube videos that she makes about algorithms. The reason why this came up recently is because just a day or two ago, she released a talk that she gave called "LERP Smoothing is Broken." And LERP is the sort of gaming term for linear interpolation. It's when you have it reaches its destination in a smooth fashion rather than abruptly, so it feels more realistic. You might hear easing as another way of doing that, but easing is more fixed in the way it approaches its destination, whereas LERP is kind of responsive to the changes in the destination. The reason why this perked up my ears is because the equation for LERP is very similar to the technique I use to smooth sensor inputs, like knob inputs, called exponential smoothing, where basically you take the last value and multiply it fractionally plus the new value of your pot reading, say, and you combine them together to give you a smoother thing. And both of these techniques, both LERP and exponential smoothing, suffer from the problem of they change how they look with the frame rate changing. Because the way it works is you multiply a percent of the old value, add it to a percent of the new value. If you're reading the new for exponential smoothing, if you're reading that value a lot, your resulting smooth value kind of matches too quickly your red value, and so the filtering doesn't look as good. So you kind of want to slow that down. And similarly in lerp, if your frame rate is lower, the object appears to move slower because it's not being updated as frequently. And so she talks about, and this video is great because it talks about some frame rate independent techniques for dealing with changeable frame rate. Like in her case, because she's a game person, she's like, well, some people might be playing this game at a cinematic 24 frames per second, but some person might have a high-end gaming rig that's at 120 frames per second, and those two people will have two very different experiences because the lerp will be essentially 5 times slower on the slower frames per second person's computer. And the video before that I was most enamored with was this one called "The Beauty of Bezier Curves." And I don't know, I'm sure everyone has used a graphics program like Illustrator, and they've tried to use the Bezier design tool, and it's always been a little bit mystifying to me about how the heck it's supposed to work. Like, I just want the curve to kind of look like this. How am I supposed to do that with these control points or whatever? And this like almost hour-long video talks about the math behind Bezier curves and explains what's going on and gives you a sort of intuition as to what's happening with those control points and why you would put them where you'd want to put them. And so it's, I don't know, plus her animations she does for these videos are just spot on, so wonderful looking. So I say put this on. You might learn some things. If not, it's really cool to look at.
Yeah, it's on my list to watch. I didn't get a chance to watch it before we recorded, but it sounds really neat, especially the Bezier curves one, because as you said, that's just a mystery on how that works.
Totally. And then one last video is if you're doing anything in say CircuitPython, Arduino, with any type of little video game you want to make or any sort of little generative art, you almost will always be using vectors. Vectors are really just two numbers, like usually X comma Y, that you use to represent a position in space or maybe a direction in space. And you usually want to combine vectors. Like if you're a spaceship has a velocity, and when you push the go button, you've got a thrust acceleration vector that needs to be added to your spaceship's velocity vector. How do you do that? And so there are many different ways to multiply vectors. Some of them give you interesting information, like how close the vectors are pointing towards each other. Other ones would be like how to just scale a vector. The other is how to tell, like together, what direction the two vectors are sort of pointing right angles to. So like if you have an X and a Y, if you look at them in a certain way and multiply in a certain way, it'll tell you which way is Z, which is really handy. And so she goes into this really, really great discussion as to how to think about the many different ways you can multiply vectors, because it's not a straightforward thing just as multiplying two numbers.
And you used it in a game, I understand.
If I would have watched her video, I might have been able to write my little arcade game called CircuitPython Steroids a little faster, because a lot of this vector stuff I learned way back in college and kind of forgot, because when I was doing web stuff, you don't really use these sort of game vectors.
Right.
Okay, Paul, what's your number 3?
My last one is the CircuitPython Online IDE. So as folks who use CircuitPython know, there's a number of ways you can program your microcontroller in CircuitPython. Most folks just plug it into USB and use a text editor to do it, but you can program it over Bluetooth. There's now the web workflow where you can do it wirelessly. And there's also code.circuitpython.org where you can use a Chrome-based browser and program it right there in your browser. River Wang has also created an online editor for CircuitPython, which I've linked to in the show notes. It has some really innovative features, and if someone was going to ask which online editor they should use, this is the one I'd pick over the one that Adafruit developed. When you first load the web page, it has 3 steps for you to connect, making it super easy to understand. You install CircuitPython on your microcontroller if you haven't done that already, open the CircuitPy drive, and then connect to the serial port. That's it. It also has a nice YouTube video embedded with a quick start guide for additional help if you need it. Once you're connected, there's a folder view on the left that lists all the files on your microcontroller. That's something that code.circuitpython.org doesn't have. So you can edit your settings at TOML, you can edit your code.py. You just double click to edit it, and the file opens right there in your browser. The serial console is on the right, making it really easy to see if you have any errors in your code or what's going on behind the scenes. A couple of things that set it apart is that it has tabs, so you can have multiple files open right in your browser. It has easy access to Control D and Control C as buttons. So if you want to stop or restart the program, it's just click of a button in your browser. And it also has a plotter function similar to Moo, though you have to add some code to make the plotter work, but it has a good example to get you started. I think that's pretty cool because a lot of people graduate from Moo to a text editor that no text editor that I've seen other than Moo has that plotter built in. The other thing I think is just awesome is I love seeing community members create projects like this. It shows the growing community around CircuitPython, and you don't always have to rely on Adafruit for everything. I especially like how River is driving innovation by using the browser to write your code. Another interesting use case might be hosting your own server. I can see a classroom environment doing that, especially with Moo not getting a lot of love the last couple of years. There hasn't been a Moo release in almost 2 years. A couple of the bugs are starting to surface. But if you're interested, check out the links in the show notes to the online IDE and give it a try.
Yeah, I follow River on Mastodon, and I'm really impressed whenever they make an update to it because it just keeps getting better and better. I didn't know about the plotter function. That's one of the things I really miss about the the Arduino IDE is it's got a really good serial plotter. It's kind of a hidden like special feature of the app. And sometimes I will actually open up Arduino just to run the serial plotter for a CircuitPython sketch, just so I can get the really good plotter. But that's really troublesome because Arduino likes to sort of try to connect to the serial port when you're trying to use it. So it'd be nice to have it all in one thing.
Yeah, I agree. Well, that's our show. For detailed show notes, visit thebootloader.net. You can follow Todd and I on Mastodon. Check out thebootloader.net for links to that as well. And we will see you next episode.
Stay positive.